Yeah. So like today like we are discussing regarding regression. Okay, the agenda is to discuss about regression. And let us start with a scatter graph. What is a scatter graph? This scatter graph is nothing but a graph whereby, generally we take one of the variables in the x-axis, one of the variables in the y-axis, and we see here that there is a kind of some curvature forming, correct? So what do you understand with this? So with this scatter graph, we are trying to see the correlation between two variables. Okay. For example, total cost at different levels of output can be plotted. The independent variable is plotted on x-axis. So where do you plot the independent variable?
X-axis.
Yes. You plot the independent variable on x-axis and dependent variable on y-axis. Of course, your total cost depends upon the output, correct? So output is nothing but production levels. More production, more the total cost. So this is independent variable, this is dependent variable. Now, scatter graph seems to show a linear relationship. There is a correlation between two variables. Yes. We can estimate the line of best fit for this data and use this information to help predict the total cost at future levels of output. Fine. See, definitely if you have the equation with you, or if you have a line of best fit, suppose the line is going in this direction, so can you predict the or estimate the total cost when the output is increased beyond this level? Can you do that or not? Hello?
Yes, sir.
We can do that, of course. So this is like 200 units, 400 units, 600 units, 800 units. The graph is plotted for these many. The total cost is available like 400, 800, 1600, 2000. Now can I predict that what will now with this, can I estimate how much will be my cost if I produce 1000 units? I can.
Yes, sir.
Of course. Yeah. Two main techniques for estimating this information are high, low, which we have already done. Linear regression. Because if you want to find out the total cost, what will you do, Hamsika? You have to find out the variable cost and fixed cost. And this you have learned already from which chapter? Previous chapter. With the help of which method? High-low. Now in this chapter, we are going to use linear regression to estimate our cost. Okay. So this is a particular line whereby this is the y-intercept, whereby a line touches y-axis. This is the slope, which is always constant, and I told you slope coefficient b is nothing but change in y-axis with respect to change in x-axis, correct? Now, and this is b constant, this is a which is constant, and x is what here, Hamsika? X is independent variable. Are you following?
Yes, sir, following.
And y is dependent variable. Okay, so you can make a note of this, Hamsika. We'll move forward. Okay, already explained this thing, and I'll move to the linear regression. Once you can have a look through, I'll move forward immediately.
Yes, sir, done, sir.
So all these things are there, and here y is equal to a plus bx. Y is the dependent variable. So y here we are taking as cost. We will find the cost based upon the independent variable, which is going to be the output. and this is always going to be fixed, so A is nothing but the fixed cost. And like B is nothing but it represents a constant. Variable cost per unit is always constant, that multiplied with the output levels will become the total variable cost, and this will always be fixed. Total fixed cost and total variable cost will become the total cost, and then you get Y. Correct? Yes?
Yes, sir.
Variable cost per unit, total fixed cost. Variable cost per unit into output becomes total variable cost, and total FC plus total VC is nothing but the total cost. Make a note of this.
Done, sir.
Linear regression. So now the thing is, we have seen the equation. Linear regression finds an equation for line of best fit mathematically. Line of best fit is nothing but all the points whatever you plot on a graph would lie on some line. Maximum points would lie on some line. Then this line can be termed as line of best fit. Okay. Once an equation for line of best fit has been determined, forecast can be made. The equation represents the trend of the data. Of course, once you have an equation of this kind, then what you can do, you can estimate the future costs. How? This is not going to change for any output levels. This is going to be fixed because this is per unit variable cost. We have already seen the nature of the variable cost. Only this is going to change. And if this is gonna change, this is definitely gonna change. Or if this is what you have, like if you want to put some figures on this for future estimate, and you can get the estimate for this. Okay. Now B's formula is this, and when you have this B's formula, so like there's no need for any derivation regarding this formula. You have to just note down, and when you know B, you know Y is equal to A plus BX, you know the B value. So Y minus BX can give you A value. Is it right? Yes. So you get the fixed cost as well. So please make a note of B and A values, and here this is the average of Y minus B into average of X, okay, is giving you the fixed cost. Just make a note of this, Hamsika, and we will solve a question right now. Okay, we will make a regression equation and we will try to find out our cost. Fine. Okay, let's go.
Yes, sir.
Make a note of this.
Yes, sir. Done.
So again, you have X and Y. Okay, these are the outputs. These are the total cost. You know this you have taken X. This you have taken Y. So what you need to find? See, first thing is you have a task here. You have to find out the B value. B is gonna be sigma xy. All right. And no, sorry. I'm extremely sorry. To find out B, what do you want, Hamsika? You want sigma xy or not?
Yes, sir. Sigma xy
Sigma x,
and
sigma
n.
y, sigma x square, and sigma x, whatever you get, whole square of that. That's the second thing. So you want sigma x, sigma y, and sigma y square, and as well as sigma x square. Correct?
Correct, sir.
But sigma y square is not there. Sigma x square we want. Okay. And also we want sigma xy as well. So already we have put that. And sigma x, sigma y multiplied. Okay. But y square is also required. No? In equation, I'm not seeing any use of y square. Sigma y square also they are finding. Okay. So now this is the data, and the data is very clear. You find out all the values, Hamsika. That
Okay,
is
sir.
x, y, x square, xy, and totals of all first. And then you have to find out the b value, Hamsika. Okay. Find out the b value. Find out the a value. I'll show you. Then we'll go for the total cost. Will you do this?
Yes, I'll do it.
Without seeing, huh? Okay.
Yes.
I'll put everything here. See, this is the data. Take a screenshot of the data.
So 1 second.
You can take on Skype only. Okay, if you're taking on phone, no problem. Once you have taken this, I'm
Yes,
showing
I'll
the,
take.
yeah, I'm showing the formula. Yeah. This is the formula. Okay, do this. Yeah, Hamsika finished? Hello.
So 1 minute, sir. Almost done.
Okay, okay. Okay, let's check the answer what you've done. You can tally this. Did you get all these values, Hamsika?
Yes, sir, I did. So 1 second, sir. I'm almost getting the equation. I'm almost done.
Okay, okay, okay.
Sir, I'm getting 22,000 is equal to 28 plus 2.6x.
See, you got A as 28,
Yes, sir.
B as 2.6.
Yes, sir.
Then Y is equal to A plus BX. So Y is what actually? Your total
22,000.
cost. Yeah. So A is what? 28 plus Y is equal to A plus B 2.6 into X. What is the X? Output they are telling you to take 22,000 units. So I'll take 3 zeros omitted 22, correct? So will I get the total cost as 85,200?
So why are we omitting the 3 zeros?
They are asking, like, it's easy to do now. If you take 3 zeros, that's okay. If you don't take even, that's okay.
Okay, sir.
You don't take 3 zeros and do now, it will be easy calculation. That's it. Understood?
Yes, sir.
Now, this is the homework for you. Okay. Okay, not homework in the sense I think they have given something to deal with. Yeah, no, homework. It's an activity. Will you do this?
Yes, I will.
Okay. Now coming to reliability of regression line. So the formula applied will find a value for A and B. And hence a formula for the line, of course. The usefulness of this formula for predicting results in future depends on how strong the correlation between two variables is. That's all right. Interpolation means using a line of best fit to predict a value within two extreme points of observed range. You can take the line and you can predict any value with any extremes. Okay, that means you can take any x value and find out y value. Extrapolation means using a line of best fit to predict a value outside two extreme points of the observed range. That means, see, a range of, suppose if I fix a range here, in this you can take any values and you can find out your you can take any values and you can find out the desired results. That means you can take any value of x and find out y value. Extrapolation means you are taking values beyond this range. Are you understanding?
Yes,
Hello?
sir.
Yeah. So advantages and disadvantages of linear regression analysis. Advantages: gives a definite line of best fit, of course. Can be utilized for prediction. And many processes are linear and so are well described by regression analysis. Disadvantages: see, only linearity can be shown. But do you think always there should be a linear relationship? No, there can be a curvy linear relationship also. There can be a convexity also. I mean say there can be non-linear relationship also. Do you think always you'll be getting only straight line graphs? No, you can get a graph of this kind, correct?
Correct, sir.
And observations used may be a typical. Historic data is used and patterns may change in future. Each observation should be independent from others. Forecasting usually involves extrapolation outside the given range of observations where working conditions and therefore cost patterns may change. Yeah, because always you cannot take the values inside, you have to also take values outside the range. Already done. So Amsika, next topic is time series. Shall we start it afresh tomorrow? Because we have 8 minutes almost. So I'm thinking to start this afresh. If I take up right now, I have to again stop. Correct? Hello?
Okay, sir.
It will be better now if we start it afresh.
Yes, sir.
Only time series and index numbers is left over. So next class we can target both of them. Okay? So that is tomorrow. Tomorrow we'll finish. Tomorrow. If I have time, I'll try to take your class tomorrow, Hamsika. Okay? I'll inform you.
Yes, sir.
I will try. Like you have holiday, it seems, tomorrow, correct?
Yes, I do.
So I will see. I will try my level best. If happens, I will try to take. And then next chapter is what? You do the activity today, okay?
Yes, I'll do that.
This chapter is no materials not. It's forecasting. What's the next chapter? Acha, next chapter is about this one, na? Measures of central tendency and all. Okay, I'll inform you in prior, Hamsika, about tomorrow's class. If time permits, I'll try to take. Okay.
Okay, sir.
Okay, Hamsika, finish the activity and if I take up, okay, let's see. The time is there, so let's take up at least 10 minutes. Also, no problem. Let's take time series. See, time series. A time series is a series of figures or values recorded over time. Okay, like previous year, like previous 5 years, you may have every year you do some activity. So what you do is you see the trend. Actually, you are recording the values and you are over the years, and those values you can use for your future forecasting or analysis. Correct? Now, some example. Hello.
Yes, sir, I can hear you.
Yeah. So if you have range of values, you can forecast the future. Correct? So some examples: output at a factory each day for last month. Of course, last month's data we have, every day's output we have. So with that, if we try to frame a graph of like output and cost, can we see that every time our output is increasing and our cost is increasing? Can we do that with the help of data what we have? Correct? Okay.
Correct,
And
sir.
this shows what kind of trend, Hamsika? Increasing trend, correct?
Yes, sir.
So if you have data, you can find out the trends, na? Total cost per annum for last 10 years, monthly sales over last 5 years. Some of the components of time series. See, in time series, over a period of time, you encounter many things. One is the trend. Trend is either increasing trend or decreasing trend. Increasing trend shows a line upwards, decreasing trend shows a line downwards. Then you see seasonal variations. See, during the season, when like you see during the Christmas season, there's a lot of sale of cakes in the market. The cake sales immediately go up, correct? During the Christmas season. And other seasons, you see a normalcy, in the sense the sales are not abnormal, but during the Christmas season it's abnormal, correct? So seasonal
Yes.
variations. Then cyclical variations, like cycle is you start from a point and you end up at a point. You, what variations you see in that. And then random variations. Random is, we don't know when it can happen. Okay, unpredictable variations, we say. What we say?
Unpredictable
That is
variation.
during floods, hurricanes, and nuclear war. At most sudden, the things, your sales would stop. And during COVID-19, at most sudden, the pharmacy, the people who were having the medical shops or pharmacists were having like a huge amount of sales. Correct? No.
Yes, sir.
So we can see like in time series there are some models. First is additive model. In that we add trends with seasonal variations, with cyclical variations, and with random variations. When we add up all this, we get time series. What we get?
Time series.
That means over the period of time how the data is behaving, by taking into consideration all these things, like what is the trend during seasons, how the variations are during the uh, like uh, like during a particular cycle, what variations we have seen, and the random irregular variations. Okay. And yeah, so in this particular syllabus, what you are doing, we are only going to study about the trend and seasonal variations. So we are going to take only these two, and then comes the multiplicative model. Again, that all things will be multiplied, but for our syllabus we only consider this. Okay. Moving averages nothing but there'll be a data of like odd number of years or even number of years, and then what we do is we find out the averages. Suppose the data is of even, suppose you have 8 years data. Okay. So what you do is like you take 4 years totals, and then you take 4 years average. Then again you have like 4 years average twice, correct? Again you take those two years total. Again you take average. So this is called moving average method, correct?
Yes, sir.
Understood, na?
Yes, understood.
And this is a trend. You can see increasing trend. There's an example of moving averages, Hamsika. You have this data, and we have this 1, 2, 3, 4, 5, 6, 7 years, and they're asking us to do moving average over a period of 3 years. They are asking us. So what we'll do, we'll take 3 years data. 1, 2, 3. We'll find out the average of that. Correct? We have this. Again, similarly, we will take next 3 years, like 380, 460, 450. Again, 460, 450, 470. Again, 450, 470, 440. Again, 470, 440, 500. Correct? All the years averages we are going to do. Correct, Hamsika?
Correct, sir.
So moving totals of 3 years and moving averages of 3 years. What was the moving total? 1230. And what was the moving average? 410. So you have this, they have calculated. Will you do that, Hamsika?
Yes, I'll do that.
You can go for seasonal variation next class. At least this, at least we have utilized our time now. That is more important. Do this. I'm waiting.
Yes.
Yeah. So that tomorrow index numbers we can target.
Sir, the over a period of 3 years, the first 3 years, sir.
First 3 years, then next 3 years, then next 3 years. It
Okay.
goes on in that way, Hamsika.
Okay, sir.
Yeah, see, you can do it as a homework as well. How? You take first 3 years, then this 3 years, then this 3 years, then this 3 years, then this 3 years. You get the moving totals, correct? Hello?
Correct, sir.
And then you divide by 3, moving average. Finished.
Okay, yes, sir.
You have to leave one thing, one like column here, one column here. So you can finish that. We'll start from seasonal variations tomorrow, Hamsika. Okay?
Okay, sir.
And then comes the index numbers immediately. Yeah. So whenever next class I take, I'll finish this chapter.
Yes, sir. Okay, sir.
Okay, Hamsika. Thank you.
Thank you, sir.
Thank you.